The first thing you need to know about water is that water is a polar molecule. And to learn what that means, we gotta go to the whiteboard. All right, here we are at the whiteboard. So, water is a polar molecule. Now, what does that mean? Well, what it means is that the different poles of water, or sides of the molecule, have slightly different charges. So, if we look at this water molecule, our oxygen here, it pulls those negative electrons toward it a little more than the hydrogen. So, on oxygen here, we put what's called a partial negative. That sign just means partial negative. And then, because those hydrogen atoms, those negative electrons are pulled away from them, they're partially positive. So that's what it means that it's polar. Now, this leads to some interesting bonds in water called hydrogen bonds. So, if we have another water molecule here, oxygen, hydrogen, hydrogen, this oxygen is partially negative. And so this partial positive on the hydrogen and partial negative, they're going to attract each other. So it leads to these kind of weak bonds called a hydrogen bond. So there we have a hydrogen bond. Hydrogen bond. Okay? Now the bonds that hold water together, these, between the oxygen and the hydrogen, those are still covalent bonds, which we learned about last week. So there you go. Water is a polar molecule. The first property of water that we're going to learn is that water has a high specific heat capacity. Now, what does that mean? Well, we're going to see what some fish have to say about it because it's very important to them.
Dang, man. I'm so happy water has a high specific heat. High specific what? A high specific heat. It means that it takes a lot of energy to change the temperature of water. But why do you care about that? Because if it was easy to change water's temperature, this whole pond might freeze, and we would die.
The second property of water that we're going to learn about today is called cohesion. And what that means is that water sticks to itself. The cohesion of water can be shown by looking at this tub of water. There is water in here. There, you see it? Now, into this tub of water, I'm going to set this paper clip. Well, that didn't work. Trial number 2. I take the paper clip very gently. Nope. Trial number 3, back with the original paper clip. I've got it to float on a tissue, and when I push the tissue away gently, I pushed the paper clip. All right, let's try this again. Gently setting this in the water. I don't think I did it gently enough. Can I rescue it? Okay, now all we have to do is press gently the paper away from our paper clip. We can take that out of there, and our paper clip is floating! Because of cohesion, the water molecules are sticking to themselves so much that they don't let the paper clip through. The third property of water is called adhesion. And what that means is that water sticks to other substances.
Adhesion is how plants get water up from their roots. The water sticks to the insides of the stems, which is one of the reasons that it gets pulled upwards. We can see that with this celery in this red food coloring.
Let's check out the results of our celery experiment. The top of this celery is red at the very tips of the leaves, at the very top of that stem. This shows us that because of adhesion, that water, it sticks to the inside of the stem, which allows it to move up through the plant. Amazing! Lastly, water is the universal solvent, which means lots of other substances dissolve in water.